Okay, hi everyone. Can everyone hear me?
Yeah, can.
Okay, nice. So thank you so much for turning up for this afternoon for our presentation. We are representing NUS FinTech Society Machine Learning Department, and we will just introduce our department, and then we will also showcase our projects, and notably we'll be showcasing one project on insurance tech. So yeah, these are the speakers for today. Myself, Sakti, and Yongler, we are the co-directors for ML department. And we have Daniel, who's a tech lead. And we have Nielsen, who's a tech analyst, and they'll be doing the demonstration for the project later. So defining machine learning. Many of you have different ideas of machine learning. So what is machine learning? Machine learning is a branch of artificial intelligence and computer science, which gives machines data, and we make the machines come up with insights, and we let them use the data to learn for themselves. It is basically the use of algorithms and computational statistics to learn from data without being explicitly programmed to do so. So the key point is that without being explicitly programmed to do so, which is something that has become the cost of doing a machine learning project has come down drastically because our computational capacity is also increasing drastically. So yeah, these are some common perceptions of AI and ML, like Terminator, Wall-E, Ex Machina, iRobot, and yeah, Jarvis and Iron Man. But in reality is that it is really prevalent and in almost in many devices that we see nowadays, like Siri or this vacuum cleaner, it's called Roomba. And yeah, the famous example of self-driving cars, Netflix, and many other possibilities are unlocked because of using machine learning to generate value. So what is the difference? We'll let Yongler take over.
Thanks, Sakti. So yeah, so the main difference between machine learning and traditional programming is that for traditional programming, you write a program or an algorithm, and then you input the data in and you expect an output. So you're actually creating the program itself. But for machine learning, the main difference is that you're actually giving them, generally you're giving them some data in the form of an input and then some expected output from there. And the algorithm will actually churn out a program for you so that you can test on other data as well. So this is like the main difference of machine learning compared to your normal traditional programming. So next. Yeah, so one very important thing about machine learning is that data is extremely important. I think that's something that a lot of people, when they start out in machine learning, they tend to overlook, or they do not fully appreciate the importance of good data, good quality data. So if you have a very bad badly implemented data pipeline, this will actually result in very inaccurate data being flowing into your model. So this will lead to a lot of problems like overfitting, oversampling, or just overall there's this bias that you might not be aware of just because your data pipeline is not implemented properly. And this may even lead to wrong hypotheses being drawn and conclusions being drawn from the analysis. And that would cost a lot of money and a lot of time wasted, especially if you want to implement this in your business as well. So as the famous saying goes, garbage in, garbage out. Quality data will allow you to have a higher quality model as well. Yeah. So next. So as you all know, nowadays fintech is very popular now, and many might ask, how AI and ML is impacting the finance and banking industry specifically. So I guess more importantly, next, I think most of you would, when you think of like fintech, when you think of machine learning and AI in the financial service, you think about trading, you think about algorithmic trading, high frequency trading, you think about everything that has related to the stock market. But there's so much more and so much more exciting areas in the fintech space. For example, like currently in our department, some of our past project and current projects include fraud detection and anti-money laundering. So we actually use artificial intelligence models to actually try and train up a model to detect fraud cases. And we also have housing price predictions to predict property prices based on a certain set of parameters. And yeah, algorithmic trading, that's one of the more classic fintech cases. And we also have portfolio optimization, so which is pretty interesting because we're using neural networks and logistic regression and a few regression models to actually try and optimize the portfolio. And then what we'll be sharing today, which is automated claims, which is a very, very, I would say, less well-known area of fintech, which is insurtech. So they actually use computer vision to help out with automating the claims, which my teammates will actually share with you more in depth about later. So other areas you can expect is credit risk and credit score evaluation, AI-driven cybersecurity, and honestly, in fintech and with ML and AI, there's limitless application. It's only bounded by your own imagination, what you can think about, what kind of problems you want to solve. I am a strong believer that ML can help us solve many, many different problems. Yeah, so next. So yeah, I think I will pass my time over to Daniel and Nelson to share more about their project, and yeah, hope you guys will have you guys can take over. Thanks.
Hi everyone, I'm Daniel. I'm the tech lead of the InsurTech computer vision project. I have with me today Nelson from my team here as well, and he'll be demonstrating our model later. So a brief, you'll get out the slides. Yeah. So in this,
give me a sec.
So in this presentation, we will showcase what we have done, the model and the ML that we have developed, as well as some simple steps that if you're interested in computer vision, you can actually build your own model based on your own data set and implement a computer vision model that suits your needs quite easily, because many of the code out there has been already created for us and abstracted out so that it's really easy for beginners to get started. Yeah. So maybe I'll just give a brief intro of what our project is, and next slide. So what motivated us to do this project was that we found this article on Insurance Biz Mag, which stated that NTU's income received an average of 14,000 hard copy claims per month, and to our surprise, each claim was reviewed and approved manually, which is a very tedious and time-consuming task. So therefore, in this project, we wanted to streamline claim processing by building a computer vision model that could help cost estimation for car insurance claims. And this estimated cost can then be used for detecting fraud, ensure that claim amount is within reasonable limits. So before we started on coding and training our model, we researched on how repair costs were determined and matched the different types of damages to the respective costs. So we've actually found that the location of damage was quite important in determining the cost of repairs. Having damages on different panels of the car significantly increased the cost of repairs. So that's why we also train a model to identify the different parts of the car, such as the front, the back, and the side of the car. And with that, we match the damages to their respective panels to give a better estimate of the cost. So in this project, we use two computer vision models. One is Yolo V5 and Mars RCNN to do the prediction. And later on, we also showcase that Yolo V5 is actually really easy to use, and they really made it really easy for beginners to get started. You don't need much technical knowledge and a lot of coding experience to get started. So with that, we gathered the images of our damaged cars and labeled them with VGG image annotator. So unfortunately, we only managed to gather about 140 images, and we are quite limited by our data set. Nonetheless, the model still performed decently well, and we limited our prediction classes to just two, namely scratches and dents. So initially, we wanted to have more, to detect more damages, different types of damages. We had about 5 prediction classes, but due to the limitation of our data set being rather small, with damages looking quite identical, the performance of the models with many prediction classes were quite bad. So we reduce the number of classes, and this helps our models perform better. So yeah, this is the image annotator that we actually use. And we found it to be really easy to use, and it really helped us collaborate and coordinate the labeling jobs. So it's really easy to use and really lightweight because it all fits into a single self-contained HTML file. And one benefit of using this tool is that you can easily convert the label image to the compatible formats that are popular with compatible formats which are popular with computer vision models, such as the Yolo V5. And we'll show you a method later they can actually use. It's quite easy to use. It's just a drag and drop function. And if you need more control over the formatting, you can actually export the labeled image to a CSV or JSON file format, and then format it from there using pandas based on the requirements of your pre-trained ML model that you are planning to use. So following that, we also perform data augmentation by adding noise, blurring the images, and changing the contrast and brightness of image. So we use the image, the IMG AUG package in Python that allows us to actually randomize the data augmentation. So we could turn on and turn off different augmentation effects randomly during the training process. And this improved our model's performance significantly, especially since our data set was very small. So yeah, next, Nelson will share more about the models that we use.
Okay, thank you, Daniel. So why do we use MassRCNN? So when looking for deep learning-based object detection models, region-based convolutional neural networks appear to be one of the more popular algorithms for object detection. So actually, MassRCNN is one of the most recent evolutions of the RCNN family, and it is capable of performing a pixel-level instance segmentation. We also thought that this instance segmentation feature from MassRCNN would be a great addition, as it can very precisely outline the damages. Another factor that made us choose MassRCNN is that it is very simple to train, and it is easy to be generalized to other computer vision tasks. For instance, in this image, you can see it has also been used for object detection on self-driving cars. For the training of the model, we fine-tune a pre-trained MassRCNN model on our dataset of damaged cars. So we first train around 70 epochs only on the heads layer, and again 50 epochs on all the layers. The model still performed very poorly with 16.6% test MAT. So we decided to improve the performance by adding image augmentation, because with very small data set, we do not have enough variety in our data set. So by adding this augmentation, the model can capture small patterns under different angles, different lighting conditions, and different image resolutions. And initially, we trained the model on 3 classes, but we decided to merge 2 classes into 1 class, as we realized that we had only very few examples of the other class, and thus the model was not able to capture the patterns of that class properly. So combining these two, after utilizing image augmentation and cutting down the number of prediction classes, we trained all of the layers for another 50 epochs, and it showed significant improvements where the test MAP rose to 50%. And after observing the validation loss for the last 50 epochs, we decided not to continue training, as we suspect the model to overfit to the training data. We then used the best model weight that achieves the 50% test MAP on our website for the prediction. And next up is the Yolo V5. So Yolo V5 is another popular object detection model, which often boasts its real-time object detection capability. It has also found its way to object detection for self-driving cars, as it offers very low inference time. Even though these Yolo models are very small, they also offer very high accuracy, where they even outperform MassRCNN on Microsoft's Coco dataset. This makes Yolo V5 a very suitable model for our application. So when training for Yolo V5, there are different pre-trained object detection rate sizes. So there are small, medium, large, and X large. And as it can be seen, the model's weight size, as the model's weight size increase from small to extra large, there's an increase in MAP, but at the expense of the inference time. We then train on 3 weight sizes, only for small, medium, and large. And when we finished training, we found out that the weight size that yielded the highest MAP on our data set was the Yolo V5 large. So fortunately, as low inference time is not our main priority in our application, we decided to use the weight from the Yolo V5 large for our website, as it achieved the best results. So these are some of the predictions from the left is the Mars Arsenien, and to the right is from the Yolo V5. So overall, the results from both Mars Arsenien and Yolo V5 peaked at about overall 50 to 60% test MAP. Since both Mars Arsenien and Yolo V5 model are trained on this dataset peaks at around the same MAP, we suspect that the size of our dataset is the performance bottleneck, and hence we stop training. For the location detection, it is only trained on Yolo V5 with 3 classes. That is the front of the car, the back of the car, and the side of the car. We did not train the location detection using Mars Arsenien, as we only needed to know whether the damages are front damages, side or back damages. And hence, instant segmentation may not help very much in this case. So these pictures are some of the results, the location detection performed on some of the damaged cars pictures. Okay, so now I will be doing a live demo of our website, which hosts both of the models. Okay, give me a sec. Let me share the website. And yeah, everyone should be able to see the website. Okay. So in the website, the user can upload pictures of their damaged cars. And let's say we pick this image. We can see that in this image, there are some scratches, there are some moderate sketches here that the model should be able to pick up. And what the user will do, then it will submit the picture to our website, and then we will output them the predictions on the website itself. Yeah. So this is the result of the predictions. To the left is the Mars Arsenien output, where it outlines the damages using this polygon. And to the right of it is the outputs from Yolo V5, where you have the location detection, where it correctly predicted the front, it being the front damage of the cars, and then it also predicted the scratches. And so we have 2 classes, scratches and dents. So let's try picking another image where the cars have some dents. So okay, so we should give some time for the backend to reload. And okay, then it should it's reloading. And yeah, in this image you can see that there are scrum scratches on the cars, and there are actually a dent here, right? There's a dent here, here all the way to here, right? So when we submit the image, we will get the same prediction. Give it 5 seconds, and yeah, it actually predicted the scratches that were in the front part of the cars, and it also predicted the dents right here, right? So to the right is also the output of the Yolo V5, also predicting the front of the cars and the dents of the cars. So this is the cost estimation that we came up with, which is just a very simple cost estimation based on our research. Okay, so that's it for our live demo. So I will be sharing the slides again. Okay. Okay. So from our project, we do have some improvements that needs to be made. For example, because of our very limited data, we could only identify 2 classes where there are only scratches and dents. So for further improvements, we believe that if more data is available on these classes, we can increase the number of classes and extend the model to identify damages such as windshield cracks, and separating the dents to, let's say, a moderate dent and a severe dent. And these will in turn help in providing a better estimation of the cost estimate for the insurance claims of the damaged cars. So next, Daniel will share more about how the project can be integrated the businesses. Yeah.
Yeah, so you've seen a live demo of our project. So after training the model, we plan to deploy this as an API so that the model predictions can be used in the insurance management platform that NUS FinTech Society plans to build. And this online platform is not only useful for insurers to manage insurance claims digitally, but also for the insured to view their policies and make it a convenient place for them to submit their claims. So we plan to make this this computer vision project also available for the insured to upload his car damages so that users can actually get an estimate of the cost of repairs. And this way, the insured can perhaps get a better idea of how much it would possibly cost him to repair and make a more informed decision on whether to make a claim by weighing the benefits and the cost of the potential increase in premiums and upfront cost of the repairs. So for insurance companies, this online platform could also be a place for them to organize and track insurance claims digitally. And this could help them reduce paperwork and simplify approval processes, especially with our ML solutions such as ours to assist them in processing the claims. This could greatly improve productivity for insurance companies. So another potential extension of this project is the use of more information to supplement our predictions based on the information on insurance records. So one limitation of our project is that the cost estimated does not take into account the model of the car. So we know more luxurious cars and brands would probably cost more to repair given the same damages. And given that insurance firms probably hold a record of the insured car brand and model, we could then use this information to supplement our predictions and give estimated cost that is more specific to the brand and model of the car. So after this, you may want to start your own computer vision project. And I know ML can get quite complicated and it may first seem very daunting for beginners to get started. That is why we have a few simple steps that could help you get started. And if you are new to ML, and these steps are the steps that actually we followed and it helped us complete this project in a short span of 2 to 3 months. Yeah. So the first step is research. So we realized the importance of this step. This step really helped us understand the problem better and determine the end product that we wanted to develop. So in this step, it is important to understand how decisions are made, how the target variable that you want to predict or classify is determined, so that you can identify the number of prediction classes that you can set and the type of data that you need to train your model. So for us, understanding how the repair costs and were determined made us realize that the location of damages was quite important in giving an accurate estimation of the cost. And hence we developed a model to detect the car panels and overlaid that with the damage prediction to get a better estimate of the cost of repairs. So another crucial part before starting the project is actually doing sufficient literature review to explore what others have done and identify what worked for them. So we found a number of projects experimenting with mass RCNN to do damage detection, for example, detecting cracks on the road and detecting damages on products from manufacturing processes. And from there, we thought maybe this could be applicable to car damages as well. The second part is data collection. So this is probably one of the most critical steps of ML. And without good and clean data, the performance of models will be severely affected. So one way to get reliable, good data is from open source data sets that are made publicly available. But usually the real value comes from internally collected data by your own company. So setting up the right data collection processes from the start can help facilitate the adoption of AI. So the third step is data labeling. This part is quite tedious, but with the right tools, you could split the work and even outsource the labeling jobs. So we found VGG image annotator to be really useful and easy to use. And you can easily download it by you can just Google VGG image annotator, and there's a website for you to download the annotator. It's just a simple HTML file, really lightweight, and it's really easy to get started because there's detailed guides there to guide you along on what tools you can use. So as shown here, we start with the image on the left, and then we use the polygon tool to select the area of interest, which is shown on the picture on the right. And then we just click the checkbox right at the bottom to tag the selected area to the right prediction class. So if you need a bounding box, the polygon shape is more for the mask RCNN because mask RCNN is for image segmentation. But if you need a bounding box for Yolo V5, there's also a rectangle bounding box tool there as well that you can use to make a rectangular selection of the area of interest instead. Yeah, we also like VIA as it's not too difficult to convert the labels of the image to the right formats of the model that we intend to use. Yep. So in fact, if you look to the left, there's a couple of popular computer vision models that have shown to be really accurate and powerful. And there's this solution by RoboFlow that helps convert your label image in the VGG image annotator to the right formats, such as the format used by Yolo V5. So the video on the right, you can see that it's really easy to do. All you need to do is just go to the RoboFlow website, drag the label images and the VIA annotations right into the RoboFlow website, and they'll convert all this for you into the right format, which is the text file for Yolo V5. And this can really help those who are not familiar with pandas or data manipulation to prepare your data set for training. So once your data is all prepared, this is the exciting part, right? This is where you train your model. So building your own model from scratch, it's very time consuming and it may not yield good results because deep neural networks take time to train, and they have very complex architecture that it takes time to understand and to implement. So for computer vision projects, it might be actually good to take pre-trained models and further train them based on your own custom data set. So this is a process known as transfer learning, and it gives beginners the opportunity to stand on shoulders of giants, people who have done extensive research in the field and have created really complex and powerful architecture. And you can, from there, take their models and train them on your own data set to achieve good model performance, despite having really little resources. And even as a beginner, you can get good models from there. So one way you can get started is the Yolo V5 computer vision model. Ultralytics has an easy to use implementation of it with really detailed guides on how you can feed in your custom data set. So it's really not difficult. All you need to do is actually convert the coordinates of your bounding boxes into text files as shown on the right. So for each image, for each row, for each image, you have a text file, and each row, the first number represents the class ID. So the class ID 0 represents the person in the example on the right. And the second and third number actually represents the X and Y coordinates of the center of the bounding box. And the last two digits actually represents the width and the height of the bounding box. So yeah, is that straightforward? And then from there, you can follow the code examples in their GitHub page and train your model to detect the objects that you want. And it's actually a really simple process because they provide really detailed codes that you can just take from their GitHub page. And it's actually just calling they already implemented all this for you. All you need to do is just import their packages and call a train function from their models based on your data set. Yeah. So another benefit of the Yolo V5 is data augmentation is automatically done for you when training. So they resize and flip your images and apply various augmentation effects on your images to improve accuracy. So you don't need to worry about doing them manually. Like what we have done, we use the IMG AUG package to do it manually, but you don't need to worry about that. Yolo V5 takes care of all this for you. So with that, you might need some extra computing power for training. So computer vision models, deep neural networks, they take time to train and require a lot of computational resources. So AWS, Amazon Web Services, actually offers free tier usage for SageMaker platforms. And you can actually take advantage of that. These are the benefits of the free tier. So on AWS, you could actually, they also offer instances that are optimized for ML training, and you can leverage on that to speed up your training. So especially computer vision models takes a very long time to train. So it might be beneficial for you to actually train these models on the cloud and initialize instances on demand. So your computer may be actually limited by the amount of memory, amount of RAM that it has, the amount of CPU power, and it takes a long time for the model to train. So you don't want to be having the model training like for the whole day on your computer when you need your computer to do other work. So you take your training, take your code, place it on the cloud, on SageMaker, and then initialize instances on demand to actually train your model. That's a more cost-efficient, cost-effective, and also a more time-efficient way of training your models. So even if you're not eligible for the free tier, the cost of running instances is actually quite cheap. It varies from a few cents to maybe $1 per hour or two. So for our project, we actually use AWS SageMaker to train our model, and we actually let it run overnight throughout the day. And in total, I think training the model only costs us a few dollars. So it's really quite accessible and cost effective for people who are just starting out. So AWS also offers many other solutions for subsequent deployment after training. So you could deploy it on Elastic, the EC2 instances, and you can also deploy it as a Docker container, and they will provide other solutions for deployment as well. So other cloud providers such as Google Cloud Platform, GCP, and Microsoft Azure may also provide similar services. So feel free to check them out as well. I believe they have some free tier as well that you can actually leverage on. And the services they provide may actually be quite similar. So if you're more comfortable with any of other cloud providers, yeah, feel free to use their platforms as well. So with that, thank you for your time, and hope you found this session really useful for your own project. Yeah, and you can feel free to ask us any questions that you may have now. Yeah, maybe if nobody have any questions, maybe I can just talk a bit about the mass RCNN model if you are also interested. Maybe now so you can go back, or you can stay on this slide. So mass RCNN is also implemented by Matterplot, and you can actually get the whole model on the GitHub as well. So what we did was we actually forked the GitHub repo, and we actually from there use the implemented different layers that we have implemented in TensorFlow to actually train our model. So it's actually really quite easy. There's detailed guides as well to actually follow along. But I think mass RCNN is a bit more complex. It's not as easy to use as Yolo V5 because there's much more code that you have to deal with. But if you know TensorFlow and you're comfortable with that, then definitely it's quite possible to figure your way out and train a image segmentation model. So image segmentation, I believe, is maybe slightly harder because we are not only detecting bounding boxes, but actually the mask that we are actually detecting. So it's more there's more precision required. Yeah, so for the Yolo V5 is also on Ultralytics GitHub page, and you can search it up, and you can actually just fork the repo and get the implemented model. It's actually implemented in PyTorch, and I think another programming language as well, but the one we used was PyTorch, and from there it's just a matter of importing the Python files from your training, from the implemented model that they've created, and calling a train function of that by directing the model to the labeled the folder with your labeled images. Yeah.
Daniel, hi. Yeah, maybe I can just ask like one question just to like bounce some ideas. Like you had a damage cost estimate in the final product. I remember that. Like the final, after you scan the images, you had a final estimate. But like as you mentioned yourself, like there's many different factors that come into play, right? Like deciding the cost of the damage. So how can we improve that? Yeah, maybe you can share about that.
Yeah, I think one way we can improve that is actually having more data set, more data. So right now our prediction classes are only on scratches and dents, but previously we wanted to actually detect the severity as well. So we wanted to detect moderate dents, severe dents, light dents, and maybe light scratches and moderate scratches as well, because this will probably vary in cost. And from our research, it did vary in cost, but we were quite limited in the size of our data set. And for example, light dents wasn't too prevalent in our data set. And light dents actually cost quite little to fix, maybe like $20 to $40 is actually just to knock out the dents. So this actually is much lower than what we predicted, because right now our actually we're detecting more moderate dents. Moderate dents requires like the whole part to be replaced, or for repainting job to be done. So that would cost about $400 to $1,000. So actually the severity also matters, but we aren't able to detect that because there weren't enough light dents in our data sets to actually train our model. So I think maybe if we had like 1,000 images or even more than that, I think our prediction might be better. And also I think for the location, right now we're only detecting side, front, and back, right? So different having damages on different panels also affect the cost. And imagine if you have a damage to your front door, and then on the same side to the back door you have another dent, that will actually double the cost from what we found. So right now we're only detecting just side, and that may not be the most accurate, because maybe we should detect front door and back door. But we didn't want to do that because we're already facing issues with the prediction classes for the damages, because our data set is quite small. So we just focus on side. So I guess we could explore front side, back the back of the door, the back door, and maybe for the windows as well. We can also detect the location of the windows, because actually the cost of fixing damages to the windows is different from dents and scratches. So we also didn't detect any window damages, because in our data set there weren't there weren't any. Yeah, I think there were only very few, and there are too few to actually have good performance. So with that, I think another extension to this project will actually be finding more data set damaged windows to actually train our model. Yeah.
The data labeling process takes really long, right? Like
Yeah.
So that's
it does.
So it's like a bottleneck over there too.
Yeah. So in this project we had at least had a few members, and we actually split up the workload. maybe there were about 140, so each of us took about 40 images to label. But if I'm not wrong, in the commercial setting, if you have bigger projects, you can actually outsource this labeling job. And I think SageMaker, AWS has certain services that could help that, such as ground truth labeling that could make this faster. And they have other solutions there as well that supports image annotation as well. I think kind of similar to the VIA annotator, the VGG annotator that I mentioned, but I guess you could outsource your better, make it easier to coordinate the labeling jobs jobs that you outsource and have other teams working on it as well.
Yes, okay. Yeah, thank you for sharing. Yeah. If anyone else has any other questions, we can maybe take like 1 or 2 questions. Yeah. Yeah, but if not, I can go to the last slide. Yeah. Yeah. Yeah, I think we can wrap up. Youngler, can you?
Yeah, so thank you so much for coming, everyone. I hope it shed some light to more exciting areas of fintech, not just in trading. And yeah, I think this is definitely very interesting. As we try and advance the fintech industry, especially in Singapore, it's always good to have different areas that we can explore, not just in a specific area. Yeah. So thank you so much for coming. If you have if you guys are more interested in our other projects, you can always check us out on LinkedIn or Instagram as well for any new news or updates that we have. So thank you so much for coming. Have a nice day and stay safe.